That was amazing. All right. Okay, properties of inequalities. I had already mentioned this is going to be easier than what we just did. Yes, we're solving inequalities. Listen, the only thing that you really need to remember is that when we solve an inequality, we treat it like an equal sign with one exception, and that is when you multiply or divide by a negative number. So if C is negative, so meaning like if I multiply by a negative number, the less than turns into greater than. And if it's a greater than, it switches to a less than. So for example, if I have negative 3x is less than 12, then when I solve, I get x is greater than negative 4.
Is the sign on the second one supposed to be flipped on the C? C is greater than 0.
Oh no, these okay. If C is so this is if C is positive here. If C is positive, the sign doesn't change, right? So if it's less than, it stays less than. If it's a greater than, it stays greater than. Okay? This is saying now, what if what we multiply or divide by, C is now negative? Okay? So you definitely, if you passed Algebra 1, you should have taken this topic or material at some point. So, because what do we do here? We have to divide both sides by negative 3. So I get, right, the negative 3's would cancel and I get x. But when I divide by a negative, this less than sign is going to change to a greater than sign. Okay?
When you divide by a negative on both sides.
On both sides.
But if you're doing it on one side, it doesn't.
Correct.
It's like how you flip the sides if the negative is multiply a negative by both sides.
Yeah. So another example would be, let's say I have.
You can't. You can multiply on one side. 8 times 3 is less than 12. You multiply on that one side and you don't know when you do the one side.
Okay.
No.
Okay, just a minute. Okay, let me just do one more example and then I'll answer questions. So if I have x over negative 2 is greater than 5, I would multiply both sides by negative 2. So that would give us x. The greater than sign would turn to a less than, and then I would get a negative 10 here. Okay. No, you had a question?
You switch it because you're multiplying.
Is the greater than or less than sign supposed to be the same as the hang on. Where it says the C is negative or
Is C is negative.
Yeah,
so if we have
I
something.
know. But like is the sign in between the C and the 0 on the bottom supposed to be the sign?
Yeah, because this tells us whenever C is less than 0, that means C would be a negative number. It's supposed to be that way. I promise. Okay. Exterior angle inequality theorem. So we already know that the exterior angle equals the sum of the two remote interior angles, right? We know measure of angle 4 has to equal measure of angle 1 plus the measure of angle 2. So what we want to look at in this one is how does measure of angle 4 compare to each of the angles?
Is the angle signs the same as
so they have to be greater than, so each exterior angle has to be greater than each individual angle measure. Because, for example, we can't have an angle that's 0 degrees. So no matter what, the exterior angle is always greater than
3, 2, and 1?
Not 3. Okay? We can't tell if it's how it compares. So it's always the exterior angle is always greater than the either of its remote. Whoops.
Whoa there.
Okay. Remote interior angles. Okay, so it just tells me, for example, I can give you a completely different picture, right? I could give you.
So how would 3 be?
Ooh.
What would you do?
3 does, so we can't make any assumptions with angle 3.
Well, if we figure out 4.
So if I draw a different triangle, yeah, it's okay. Let's say this is my triangle, and I label this as 5, 6, 7, and 8. Okay? So same idea. The only thing I can't determine is angle 6. Okay? 7 and 6, I don't know for sure how they compare. But I know measure of angle 7 is going to be greater than measure of angle 5. And I know measure of angle 7 is greater than the measure of angle 8 without knowing any of the measures, because 7 is the exterior angle.
That
So,
makes sense.
and you can draw an exterior angle that's acute. You can have an exterior angle that is obtuse. It doesn't matter. That's why we don't know for sure how it compares to the one that's right next to it, other than that they make a linear pair.
What's a real number?
A real number is any number that you can locate on a number line.
Wait, what if your exterior number that's not an actual?
Correct. So for example, pi, can you approximate where it would be located on a number line? Yeah, it's a little bit bigger than 3. You could put a point there. Okay. All right, so we want to use the exterior angle inequality theorem to list all the angles that satisfy this stated condition. Okay, so I want to look at all the angles that are less than angle 8. Okay, so here's angle 8. Now, what you need to look at is we have 2 different triangles that we could take into consideration. So let's take, for example, the big triangle. Do you want to do the big triangle first or the little? Well, it doesn't matter.
Oh, so 2 and 7.
And 4 and 6.
Okay, ignore all the, so let's just look at, can we compare it to angle 5? No.
2 and 7.
2 and 7. And, so angle 2, angle 7, and angle, let's look at the little triangle, 4 and 6. Good. Okay, now we want to look at,
Because if you look at the bigger triangle,
Wait, can I try this?
those
Okay.
are the angles.
Oh, yeah.
Are there
Would it be measure?
and let's say I take away this line in the middle.
It's 1.
Do you see how, like, if I take away that line in the middle?
Yeah.
It's not 1.
2 and 7. Okay.
Greater than
Okay, now we want greater than angle 2.
8.
So
1.
8 is good. So 8 is an exterior angle. That would be looking 4. So 8 is if we look at the big triangle. And what if we just look at this little triangle here? It would be 4.
What about 1?
1 is the linear.
Yeah, 1 is a linear pair. We can't tell the one that makes a linear pair.
But can't you tell that 1 is obtuse?
Okay. It looks obtuse, but we don't know until we give it an actual angle, like a number to it, that it would be. I know.
Sometimes they're
We
not
can't
drawn
go, it's not drawn to scale. Yeah, Maya.
Wait, why is it 8 and 4?
So angle 2, so in this case, angle 2 is an interior angle. So we want to see which would be the 2 exterior angles that would correspond to that remote interior angle. Okay. All right. Another picture. So given a series of angles, which one would have the greatest measure?
2.
So, okay, 1, 2, and 4.
2.
2.
What is going on?
Zoe's on it today.
Wait, why?
Because she woke up so early.
No.
All right. 2, 3, and 5. Which?
Three.
So what are we always looking for? We're looking for the exterior.
Exterior.
Okay. And we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
Three.
3. Good.
Why is it
How do you know 3? Oh, never mind.
How do I know which one?
Never mind.
Never mind. Never mind.
Circle 5.
Oh, I didn't mean to do 5.
Is the A is just because it looks.
1, 2, and 4. Okay, so 1, 2, and 4. We're ignoring this. 2 is an exterior angle to those 2 angles. Okay. Again, we're doing theorems, but remember I said we're not doing any of the proofs with this chapter. So, okay. This one sounds really confusing when we read it. It's really not. It's basically saying if you have a longer side, so let's say angle, or let's say AB is the larger side. Whoopsie. Let's say this is larger than AC.
Does it also see longer than BC?
No, we only compare 2 at a time. Okay, so let's say this is larger, this one's smaller. So AB is bigger than AC. What that tells us is the angles opposite those sides also compare in the same way. So take a look at AB. What angle is opposite AB? C. So then I know measure of angle C has to be greater than. Okay, what's opposite AC?
AB.
No, which
I
means
mean B.
yeah, B. B is opposite. Okay, so if AB is bigger than AC, then the angle opposite has to be bigger. It's like they match. Like the bigger side is opposite the bigger angle. The smaller angle is opposite the smaller side. No. Okay, let me give you just
So it's basically the only thing that's missing. So AB is missing C, AC is missing B.
So let me just give you some numbers. Let's say this is 10. I don't know. We'll just go 10, 9, and 8. Okay? So let's say I know these are the side lengths of a triangle. So if I know the side lengths how they compare to each other, I can tell you the angles. So, for example, which angle, here, I'll label this A, B, and C. Okay. So what is the biggest angle in this picture? C. So this is the largest.
Oh, so if it's opposite, if it's the bigger side, it's the biggest.
Yeah. Oh, that says
Wait, why is that
largest.
the largest? Because it's the
It's
angle
across
opposite
from the
largest
largest side.
Oh.
So A would be the
Okay.
smallest.
This is the largest because
B would be the smallest,
B would be the smallest.
and then A would be the middle. Because it's across 8
Good.
and
Why
9.
would B be the smallest?
Because it's opposite the 8.
Wait,
And
that's
the 9 is the one in the middle. This what we'll call it the middle side or middle angle. Okay, that's really what the theorem is saying. The theorem is just saying compare the sides, and that will tell us what angles we have compared to that. Is that so?
Yes.
Next one, if AB is bigger than BC, now what 2 angles will be?
measure of angle C.
C.
is greater than measure of angle A.
Good. All right. Okay, now of course we don't always have just one triangle. We might have multiple angles and triangles and sides that we're comparing. So we have to really this is where maybe a colored pencil or just kind of tracing over with your pencil. We want to compare measure of angle WXY. Okay, WXY. So I want to recognize what side is opposite WXY. 14. So I'm just going to put a 14 kind of underneath here as a quick reminder. And then XYW.
Wait, wouldn't
XYW side opposite would be 12.
Wait. 14. Wait, WXY?
WXY would be.
Angle. Okay, yeah.
So here's the angle. So I'm looking opposite.
The next one would be
And then XYW opposite would be 12. Well, if this side is bigger, then this angle is bigger. Mm-hmm. Here, quick note. If you have 3 letters, all you have to do is take the outside letters. Take a look. WXY, the side opposite would be WY. XYW, the side opposite would be XW.
Good check.
Okay, so if we have 3 letters, it's actually pretty easy to see which sides we're using. So the next one, it says XZY.
17. 15.
What's XY? 15.
It's less than.
And then
of
XYZ will be 18.
Less than.
So this time it's less than.
And the next one.
Okay, next one,
It's 12.
WYX will be WX, which is 12.
And then 15.
Okay, and so, good.
It makes it so much easier.
Yeah. Okay, now we're going to go the converse. So again, let me just draw kind of, is it okay if I just use this triangle? Now what if I gave you the angle measure? So let's say I told you this was 100. Let's say this was, I don't know, 50. And this was 30.
So AB is the largest.
Yeah, so that would make 100 the biggest side, right? This would be the largest. The smallest one would be BC, and then this one would be in the middle. Okay? Right? So you look at whichever. So the difference between this and the last one was I give you the sides, you can compare the angles. Now I'm going to give you the angles so you can compare the sides. So if measure of angle C is greater than measure of angle A,
Wait, what is the name of this dude? Or do they not have names?
some of them don't have names.
So BA.
I mean, in like the future units, are we gonna be able to?
Is
Are we
greater
gonna
than
need
BC.
these for proofs?
Say that again?
In the future
No.
units, are we needing these?
And then this one, if measure of angle C is greater than measure of angle B, then AB is greater than
Wait, is it
AC.
greater?
No, it eats the big one.
Yeah.
And if they're gonna alligator,
BC is
small and small. Then do you have to put the segment lines on?
No, because we're talking about measures.
You
So
eat the bigger one. I'm so confused when I put the segment.
Oh, you eat the bigger one.
If I don't put any point, I just think
If it's like
If I
congruent,
don't
you
put it-
don't. But if it's equal, you do. I mean, no. If it's congruent, you do. If it's equal, you don't. The line.
if I don't put it on on the test while you're putting it over it.
You do put if you like.
no.
If I do.
Okay.
Wait, what time do we end? Wait,
20.
Okay, we're fine. We're almost done. Okay. This one is a little more tricky, so I just have to, we're comparing LM.
LP is the largest.
So what side is opposite, or what angle? So opposite LM would be 59 degrees compared to LP, which would be opposite 83. So that makes this less than. Okay, now the next one gets a little trickier because why?
Oh, because it's
Okay. It could be 2 different angles. So I actually am not going to put a number here until I look at the other side so I know what angle I'm comparing.
79.
Okay, so since I'm using MN, that means I'm ignoring this triangle on the left. Does that make sense?
Yeah.
I can only look at one triangle at a time. So because MN is over here, that's how I know I'm using the 79 degrees and not the 38. Does that make sense?
Yeah. Oh yeah.
Oh, okay, so this is greater than.
Why would you use 79?
All right, now I want to compare MN, which is opposite 44,
Less
to NP, which is opposite.
44.
So less than. Okay, and then the last one here, I'm comparing MP to LP. Good. And we understand why we have to use 38 this time? Cool. So less than.
No. Oh, we do understand.
We do understand. Okay. Last one. Okay, find the value of n, and then we want to list the sides of PQR from shortest to longest. So I'm just going to draw a generic kind of PQR. We know angle P is 12n minus 9. Q is 62 minus 3n. And R is 16n plus 2. Okay, what
You can add them
all together equal to 180. So 12n minus 9 plus 16n plus 2 plus 62 minus 3n. Okay. 28n minus 3n, so 25n. Minus 9 plus 2 plus 62. 64 minus 9 would be 55. Okay, so 25n equals, so 180 minus 55. Oh, and that conveniently works out to be a whole number, 5. Which 2? Oh, I thought it said 64.
Why do we have to do so much math? It's a lot of math.
Okay, we could do this.
It's fine.
Okay, it is fine. It is totally fine. All right, let's see. 5 times 12 is 60. Minus 9 is 51. So this is 51 degrees. Okay. 16 times 5 is 80. Plus 2 is 82.
Wait, why do we have a negative right now?
And then it's 47.
There's no negative.
62 subtract 3n.
47.
So
Yeah, but
the
n is
largest-
15. So what's 62 minus
largest is
15?
QP.
I don't know.
47. QP, it goes QP.
Okay. We want to list from
QP
Shortest
to longest.
shortest to longest. So the short.
QP, QR, PR.
Wait.
Is less than.
Wait, which is the smallest side?
PR.
PR.
Oh, sure.
PR is less than.
Well, we just need to list them.
PR,
PR is less than.
PR, then QR.
QR.
And then
What's the biggest side? PQ.
Can I do it with the less than?